This videotape is intended for use as an aid to the manuals provided for the assembly of your replica kit. The videotape is not a substitute for the manual. Assembly and disassembly will vary from kit to kit. Should you encounter difficulties, consult the manual. If the manual does not give a satisfactory explanation for your problem, contact the company for assistance. By this videotape, GGL Industries or its associates does not make any warranties of merchantability, fitness for a particular purpose, or otherwise. Moreover, GGL Industries or its associates does not guarantee that the disassembly or assembly of your replica kit will be the same as that depicted on this videotape. This videotape is provided as a demonstration aid to the instruction manual that comes with your kit, and in no way should the videotape be used as a replacement for the instruction manual provided. During the course of this videotape, we will either be disassembling a Chevette or Pinto donor car, or assembling the components removed from one of these onto a new frame. The completed new chassis will be the foundation for either a stunning recreation styled after the legendary 1929 Mercedes-Benz SSK, or a spectacular reproduction based upon the king of the road, the 1952 MG TD. Before we begin, let's go over a few details. At the beginning of each replica's instruction manual, there appears a list of tools and supplies necessary for the construction of each kit. All of these items will not be utilized during the procedures covered by this videotape. We suggest that both the donor car disassembly and new chassis assembly videotapes be reviewed, along with the corresponding sections of the instruction manual, before the project is started. Pinto and Chevette specifications vary from year to year. Because of this, it is impossible to show every mechanical configuration. Factory service manuals, identical to those used by dealer service departments, are available from Helm Incorporated. These are extremely technical. Less detailed shop manuals, such as the ones shown, are available from most local auto supply stores. One of these is an essential tool and should be obtained before starting the project. Most manuals that come with the replica assembly kits have several pages covering safety precautions. It is extremely important that time be taken to review these pages. Some earlier manuals may not have the list of do's and don'ts found on these pages. Should this be the case, a call should be placed to our technical department. They will be more than happy to furnish a copy. Okay, let's get to work. The very first step in disassembling our Pinto is to remove the battery from the engine compartment. Wearing suitable hand protection and safety glasses, we unbolt the negative battery cable. Now we do the same with the positive battery cable. Then the two cables are tucked safely out of the way. Now we carefully remove the battery and store it in a safe place. The battery will be used in the assembly of our replica, so it will be necessary to check it regularly and keep it charged. An unused battery deteriorates rapidly and must be maintained. The next step is the removal of the hood. This affords easier access to the engine compartment. This is easily accomplished by using the appropriate socket extension ratchet and unbolting the hinges located on each side of the hood. The hood is then simply lifted out of the way. The car must now be completely elevated off the ground. We place a floor jack under the front cross member and raise the wheels approximately 1 foot off the ground. After the front of the car is raised, we place jack stands behind the front wheels, under the unibody. The car is now securely supported. This is a safety measure that can't be too strongly emphasized. We never work under a car that is not properly supported. Now we lower the car onto the jack stands and remove the jack. It is possible to use only 2 jack stands. However, for safety and convenience, we strongly recommend the use of 4 stands. They are relatively inexpensive. We will then have 2 additional stands for the rear of the car. To jack up the rear, we slide the jack under the differential located at the center of the axle housing and lift the rear end to the same height as the front end. The 2 jack stands are then placed under the car as shown. The entire car is now securely supported. A hydraulic floor jack can be rented from most tool rental stores or from our local service station secured by a small deposit. After the car is positioned on the jack stands, we always check to make sure it is secure. This is a very important safety measure. Before we go on to removal of the gas tank, we'd like to point out the importance of keeping a fire extinguisher in the work area. We always keep one within immediate reach, just in case of an emergency. When we are assembling the MG TD replica car, gas tank removal is unnecessary. The MG comes with its own fuel tank and filler neck. However, the 29 Mercedes-Benz SSK requires removing the fuel tank and filler neck. The first step in removing the filler neck is to take out the 4 screws securing the filler neck to the left rear fender. We make sure to save the gas cap for later use in the assembly of our replica car. Occasionally, we find a screw which is somewhat different. It resembles an Allen head, but has 6 points and is known as a Torx, T-O-R-X screw, and will require a Torx screwdriver or socket wrench, which can be purchased at most hardware or auto supply stores. Now we move to the rear of the car to remove the gas tank straps. With the appropriate socket and ratchet, we remove the nuts from the studs that secure the gas tank to the rear of the car. These are located at the back of the gas tank. After this is accomplished, we look to the front of the gas tank where the fuel lines and fuel sending unit wires are located. To remove the fuel sending wire, we cut a 12-inch lead and leave it attached to the fuel sender plug. The clamps securing the fuel line and fuel return line to the gas tank are removed, and the gas is drained into a safety-approved fuel container. After the gas has been drained, we cut the fuel vent line and lower the gas tank and filler neck from the car. Now that the gas tank has been removed, we drain any excess fuel into the approved container and tape the tank openings. Allow one small hole for any fumes to vent. The tank straps, fuel tank, and filler neck are then stored for future use. The next item on the agenda is the drive shaft. The drive shaft is easily removed by sliding under the car. Here we find the U-bolts, which secure the rear universal to the flange on the differential. A box wrench is used to remove the 4 nuts from the U-bolts. After the U-bolts have been taken out, we use a large screwdriver to pry the drive shaft forward from the differential. The drive shaft is pulled back to remove it from the transmission. At this point, it is very important to plug the drive shaft opening at the end of the transmission to prevent loss of fluid. This is done with a rag or by taping a styrofoam cup in place. Then we simply lower the drive shaft and remove it from under the car. Now we take a piece of tape and secure the bearing cups to the rear universal to prevent their loss. To remove the emergency brake yoke, we must go inside the car and lift up the plastic emergency brake housing. Then the jam nut and adjustment nut are removed from the parking brake adjustment shaft. Now the yoke is removed from the cable and saved for future use. The retaining clips which secure the emergency brake cable to the floor are at the rear of the car on both sides. A large screwdriver is used to pry the clips open and free the emergency brake cable. To complete the removal of the emergency brake cable, we look to the rear of the drive shaft tunnel. Here we find two metal brackets on each side of the car. These brackets secure the emergency brake cable to the rear of the floor recess. We remove these brackets from the car with a steel chisel and hammer. The brackets are left attached to the emergency brake cable. At this point, the cable is completely detached from the car. When performing this procedure, we always wear safety glasses. Next, we use a floor jack to lift up the rear axle housing at the center of the differential. This is very important. It relieves the tension from the springs, allowing removal of the rear end. We can now remove the tube fitting nut securing the flexible brake hose to the steel brake tube. Pull off the retaining clip with a pair of pliers. The rubber brake hose is left attached to the rear axle assembly. We inspect this hose carefully. If it is worn or the condition is questionable, we replace it with a new hose. Two bolts secure the rear spring brackets to each side of the rear of the car. We use the appropriate socket, extension, and ratchet to remove the bolts. The shackles are left attached to the springs. After inspecting the shock absorbers, we have decided to install new shocks in the assembly of our replica car. Therefore, we are only required to remove the nut, washer, and grommet that secures the old shock absorber to the mounts. The mounts are located on each end of the axle assembly as part of each lower spring mounting bracket. If we were going to use the old shocks, we would remove the hardware securing the shock absorbers to the upper mounting brackets. The front eye of each spring is secured by a bracket mounted on the underside of the car. A socket wrench is used on one end and an open end or box wrench on the other end to remove the nut from the through bolt securing the front eye of the spring to the bracket. Ford Motor Company specifically recommends that all used attaching parts be discarded and replaced with new parts when replacing a rear suspension leaf spring assembly. Although the parts may look serviceable to us, we simply place an order for 2 new bolts and nuts with the parts department at our local Ford dealer. We also thoroughly inspect the rubber spring bushings for wear and replace if necessary. Let's review the hardware we've removed from the rear suspension. These are the 2 bolts that secure the rear spring hangers to the underbody of the car. They are located on each side of the car. Next, we have the nut, metal washer, and rubber grommet that hold the shock absorbers to the lower mounting bracket. Finally, we have the through bolt and nut that secures the front of the springs to the brackets on the underside of the car. A pair of these have been ordered from our local Ford dealer. Okay, that's it. The rear axle assembly is ready to be removed from the car. We simply lower the jack slowly and drop the entire assembly to the floor. Then we roll it out from underneath the car. The entire rear axle assembly has the springs attached along with the rear hanger brackets, as well as the emergency brake cable. We're going to roll this out of the way and clean and paint it so it will be ready for assembly into our replica car. Now we go back to remove the bracket that secured the flexible rubber brake line to the steel brake line on the underside of the car. This will be used later in our build-up. Our next task is the removal of the exhaust system. We'll start by disconnecting the muffler at the rear. We use a utility knife to cut the rubber hanger that secures the back of the muffler to the underbody of the car. If the strap is in good condition, we would unbolt and save it. After inspecting the muffler system, we've declared it not usable and have chosen to put a new system in our replica car. The only component we'll be saving is the exhaust header pipe. The year of the car and the quality of maintenance exercised by its owners are the determining factors. Exhaust systems are subjected to excessive abuse, being victimized by weather, terrain, and extreme temperature change due to the interplay between engine heat and climatic conditions. Now we unbolt the header pipe from the exhaust manifold. After these bolts are removed, the system slides out and we discard everything except the exhaust header pipe. If the car has a catalytic converter, it is also saved. At this point, we call the Department of Motor Vehicles to determine the requirements for registration and inspection in the state the car is to be registered. It's time to remove the speedometer cable from the transmission. A small wrench is used to remove the cable from the gear. The entire gear assembly is what you see on the screen. Now we simply pull the gear off of the cable, reinsert it, and save it for later use, along with the nut and retaining clip. Following the speedometer cable removal, we go back to the engine compartment to remove the radiator and radiator hoses. The coolant has been previously drained from the petcock at the bottom of the radiator. We're presently removing the hose clamp from the upper radiator hose. A screwdriver is used to loosen the clamps and detach the hose from the radiator and the engine. This car was equipped with air conditioning, so we weren't able to use the original radiator. A new radiator was purchased and placed in position to show the removal procedures. After completely removing the upper hose, the lower hose at the bottom of the radiator is removed in the same manner. 4 bolts attach the radiator to the front of the car. The appropriate socket and ratchet is used to remove these bolts. This car was equipped with air conditioning, and the evaporator for the air conditioning unit is mounted forward of the radiator. We won't be using this unit, so it isn't necessary for us to remove it. We simply slide the radiator out after the 4 bolts have been removed. Let's take a moment and review the parts of the radiator. Here we have the lower drain petcock, the lower hose connection, and you'll see the overflow tube next to my right hand. Staying in the engine compartment, we find the starter solenoid on the firewall at the rear on the passenger side. We remove the battery cable and the starter cable. Then we pull off the 2 or 3 wires attached to the front of the solenoid. Whenever we disconnect a wire, we have a system for identification. We wrap a piece of masking tape around each end of the connection and give it an alpha or numeric code in order to identify the component at a later date. After removing the wires, the bracket that holds the solenoid to the firewall is removed. The bracket and bolts are stored for use in the assembly of our replica. Now we come to the air cleaner. This unit is found on top of the engine, over the carburetor. Two wing nuts hold the entire assembly together. We remove them, and the unit should come right off. The hoses to the air cleaner were removed prior to our purchase of the car. Otherwise, we'd use the same practice of coating the end of each connection for easy identification at a later date. Now we can paint the entire unit. It will look just like new when we use it in the assembly. Automotive stores sell duplicates of the factory paint colors in convenient spray cans. If we choose to retain the factory look, we simply purchase the correct matching color. Okay, now that we've removed the air cleaner, we look right behind the carburetor and find the accelerator cable bracket. The name is much more complicated than the actual part. A socket wrench with a short extension ratchet is used to remove the bolts attaching this item to the engine. We then disconnect the accelerator cable from the carburetor and remove the piece from the car. We'll have to modify this bracket slightly for use in assembling our replica. We'll take care of that at a later point. We always remember that in the course of disassembly, most of the parts that have no real movable mechanical function don't have to be replaced. If these items are properly marked, we can use them in the assembly, saving time, money, and aggravation. When identifying the parts, a neat trick we use is to mark the size of the nuts and bolts and the tool used to remove them. This is a real time saver later on. Our next item for removal is the negative battery cable, otherwise known as the ground. It runs from the engine block to the negative side of the battery. A wrench is used to unscrew the bolt that attaches the terminal at the end of the cable. At some time, this cable was replaced by the former owner. For some reason, he replaced the original black cable with a red one. Although the cable is the same size, red is normally used for the positive side. If the cables are the right color, we inspect them for serviceability. If they need replacing, we purchase the parts at our local auto supply store. Our next step is to remove the throttle cable from the bracket that secures it to the firewall. We find this bracket on the firewall, just to the right of the master cylinder. A socket, extension, and ratchet is used to remove the two bolts that attach the bracket cable to the firewall. We would like to take a moment to clarify what might have already proven to be a confusing point. When we are discussing the left and right side of the car, our perspective is from the driver's seat. In other words, we put ourselves in the driver's seat, and the driver's side is the left side, and the passenger's is the right side. Now that we've cleared that up, we'll properly mark and store our bracket for future use. We have an extra accelerator pedal here to demonstrate how the throttle cable fits into the pedal. It has to be disconnected from inside the car before we can take it out. A small plastic bushing fits into a slot on the accelerator pedal and secures the cable. The pedal is bolted to the firewall from inside the car and can be removed now or when we are working inside. All of these parts are saved, even if we decide later to replace them. Since some of these parts are so rarely replaced, we have found that the parts man at our local Ford dealer has a much easier time identifying the part when we bring the old part with us. We're now well on our way to preparing the engine for removal. We'll continue by disconnecting the various electrical components in the engine compartment. We'll start with the alternator and coil. First, we disconnect the 2 or 3 small wires from the smaller terminals on the coil. and continue by removing the large center wire which connects the coil to the distributor. We tuck these neatly out of the way so there are no obstructions when we remove the engine. It's a good time for us to remove any hoses which might still be connected. When we cut the wires from any of these various electrical components, we always try to allow a minimum 12-inch lead. During the assembly of our replica car, we'll be splicing another harness into these wires, and we want to allow ourselves enough room. After cutting any wires, we label each side of the connection with an alpha or numeric code on a sturdy piece of masking tape with a high-quality magic marker. We also identify the component to which it was attached. Now we'll cut any other wires that may be left, trying to leave a 12-inch lead. We'll save these wires for possible later use in the installation of additional electrical accessories. Moving to the other side of the engine, we remove the heater hoses. We can also disconnect the wires running to the starter solenoid, remembering to allow ourselves approximately a 12-inch lead when making the cut. Believe it or not, we're very close to removing the engine. However, we must first separate the transmission from the transmission crossmember we're pointing to. Before we begin this procedure, if our car is equipped with a standard transmission, we must disconnect the shift linkage. We refer to the instruction manual for the removal of the standard transmission shift lever. It must be disconnected from inside the car. To remove the transmission crossmember, we must be sure the transmission is adequately supported with a jack. This is very important. Now, when the crossmember is removed, the transmission will remain securely supported. To disconnect the crossmember, we use a socket and ratchet to remove the two nuts securing the transmission to the center of the crossmember. Then we remove the nuts from the two through bolts that secure the crossmember to the brackets on each side of the transmission tunnel. The jack is left in position. We take out the two through bolts and pull the crossmember out from under the car. On automatic transmission cars, we will now unbolt the transmission cooling lines, taking care to place an approved container under the transmission to catch any draining fluid. Now we're looking at the transmission crossmember with the two through bolts and nuts that secure it to the brackets. Once again, we move to the engine compartment where we're going to remove the engine mounts, sometimes referred to as motor mounts. The mounts are located on each side of the engine. Looking to the driver's side, we'll find the engine mount adapter, and engine mount adapter bracket connecting the entire assembly to the frame. It sounds much more complicated than it is. We simply put a wrench on the head of the bolt and a wrench on the nut at the other end and remove the nut. If the bolt doesn't come out easily, we leave the nut on the end and, using a hammer, tap it lightly. We do this to avoid stripping the threads. When the bolt is loose, we remove the nut and slide the bolt out. Moving to the mount on the passenger side, we repeat the procedure. This is a picture of the passenger side engine mount assembly. We can see the engine mount, adapter, and through bolt below the wrench. Now that the engine mount bolts have been removed, we must disconnect the fuel lines from the fuel pump. The fuel pump is located just forward of the engine mount on the driver's side. We must disconnect both the inlet and return lines. A screwdriver or a pair of pliers are used, depending on the type of clamps found. Once the lines are disconnected, we make sure to have a safety container ready so any gas left in the fuel pump can be properly drained. Now we're ready to remove the engine. We've removed the neutral safety switch wire and backup switch wire from the transmission. Here we have a type of engine lift that can be rented from your local rent-all store, along with the hydraulic floor jack. We've securely fastened a chain around the engine, making sure the chain is of sufficient strength to support the weight. Many engines will have engine lifting hooks. These are really L-shaped brackets with holes through them. A chain is passed through the hole or a hook is attached, and the engine is then lifted out. Either way, the important thing is to have a chain that is of sufficient diameter and strength to support the engine, and that the chain is securely fastened before any attempt is made to hoist the engine out of the car. The way we remove the engine is to simultaneously lower the floor jack that is supporting the transmission while elevating the engine hoist and pulling forward. This is not a difficult procedure. It's really quite easy and can be handled by one person with no trouble at all. Although this is the most convenient type of engine hoist to rent, there are other types which will work just as well. We use whatever is available as long as it is sturdy and intended for the job at hand. Here, we're guiding the engine with the transmission out of the engine compartment, nice and slow. In this case, we have a standard transmission. As we swing the transmission around, the weight attached to the bottom comes into view. It resembles a hockey stick on its back. This is a counterweight used to help stop engine vibration. Now we'll lower the engine, making sure it is properly supported by 2x4s or a special crate, which can be easily constructed for this purpose. With the engine properly stored, we return to the engine compartment to remove the electrical components which we'll be using later in the assembly of our replica car. We'll start with the ignition coil and bracket, which is found on the left-hand side of the car, bolted to the fender well. This step is followed by the removal of the electronic ignition module. Ford started using this unit in mid-1974, so from 1975 on, this part is found in their cars. The electronic ignition modules differ in mounting position and type, depending on the year of the car. We'll remove this unit and show you its approximate position. We simply detach the plugs at the end of the wires and take the unit out. Then we go to the voltage regulator and remove it in much the same manner. Prior to this, we have taken several photographs or instant snapshots for later reference to the mounting locations of these components. We find it's always a good idea to have the electrical components checked for serviceability. Most auto supply stores have the facilities to test the various parts in question. They usually do it free of charge. If our local automotive supply store doesn't have the test equipment, we pick up the phone book and call a few local automotive electrical repair centers. We try to establish a good relationship with the supply store. When we tell them what we're doing, they're more than happy to help, and usually we'll end up with at least a trade discount. After we've properly marked and stored the electrical components, we want to remove the motor mount adapter plates. These plates are bolted to each side of the underbody, just forward and above the front cross member of the car. 4 bolts and nuts secure the brackets to the car. By clamping the nut on the end of the bolt with a pair of vice grips or an adjustable wrench, we can remove the 2 bolts on the top and 2 on the bottom in like fashion. We then go to the other side of the car and repeat the procedure. These motor mount adapter brackets will be bolted onto the steel tubular chassis of the replica car we're building. The holes are already drilled to accommodate the brackets. The motor mounts go over these brackets and the engine is secured with the use of a through bolt. We'll clean these parts up and with a little paint, they'll look like new. At this point, we'll remove the tires and get them out of the way. We loosened the lug nuts earlier while the car was on the ground so they could be more easily removed. We'll save these tires for use while we're building the chassis and then replace them with new tires and rims when we are finishing the assembly. With the tires removed, we continue on and remove the U-joint assembly and shaft, which is used to attach the steering column at the upper end with the splined shaft on the rack and pinion at the lower end. We do this by removing the nut from the bolt at the top. The bolt will not come all the way out, so we just remove the nut from the bolt with the notch in it. At the other end, there is a flange. This flange is attached to the flexible rubber coupler. At this point, we want to inspect the flexible coupler. If it is damaged or loose, we'll be required to replace the entire universal joint, as the coupler is either pinned or riveted to the sleeve on the flange at the bottom. Our next step is to remove the tie rod ends that connect the rack and pinion to the front spindles on each side of the car. First, we'll remove the cotter pins followed by the castle nuts. When necessary, we use penetrating oil on any frozen nuts or bolts. This can be obtained from any auto supply store. We use a ball joint separator tool to tap on the ball joint to disconnect it from the front wheel spindle. We never hit the ball joint with a hammer. After we've removed the tie rod ends from the front wheel spindles, we'll remove the rack and pinion steering gear, which is attached to the front crossmember with long through bolts. Depending on the year and type of steering gear, the manual rack may be held with either 2 or 3 bolts, which are secured by a nut on the opposite side. First, we'll loosen and remove the nuts, followed by the removal of the rack and pinion assembly. We jiggle the rack a little so we can slide the long bolts out. These bolts will be used to attach the rack and pinion to the new chassis of our replica car. We want to properly identify and save all the hardware, as well as the insulators found in the mounting holes of the rack and pinion. Now we just pull the rack and pinion up and out of the car after we've removed the bolts. Here we're holding the passenger side or right tie rod. This is the rack. Then the steering shaft, followed by the left or driver's side tie rod. We inspect all the bellows and make sure the parts are in serviceable condition. These are the long through bolts that secure the rack and pinion to the front crossmember. Inside each fender well is a bracket which is used to attach the rubber brake hose to the metal brake line. We'll remove the brackets along with the clips which attach the rubber brake hose. Then we'll mark and store the brackets for later use. Later, we'll inspect the brake hoses thoroughly and replace if there is any question regarding their condition. Now we'll remove the struts that attach the front control arms to the frame on each side of the car. First, we remove the nut on the inside of the frame at the rear of the strut. Then we remove the metal washer and rubber bushing. Moving to the front of the strut, we remove the nuts holding the struts to the front control arm. After removing the nuts from the two bolts, the strut is pulled up and forward, thus freeing the strut from the car. All the hardware is marked and saved for use later when the new chassis is assembled. If this car were equipped with a stabilizer bar, it would be attached to the lower control arm. We would remove it at this time. We do not, however, use a stabilizer bar in our replica car assembly. Here we have the strut, along with the nuts, rubber bushing, washers, and hardware. The next step is very important. In order to remove the rest of the front suspension, we must place a floor jack under the lower control arm. We must relieve the tension on the spring in order to safely remove the bolts. After the jack is properly supporting the control arm, we remove the lower shock mounting bolt, which attaches the lower shock bushing to the control arm. Then we remove the upper nut, which attaches the top of the shock to the crossmember. Now we can slide the shock down and out of the car, removing the lower bolt and pulling the shock out. The jack should still be firmly supporting the lower control arm. With the jack in place, we remove the nuts holding the bolts attaching the upper control arm shaft to the crossmember. We remove the nuts and save the bolts for use in the assembly of our replica car. When this is accomplished, we pull the control arm over and away from the car. Now we slowly lower the jack to ease the tension from the spring between the crossmember and the lower control arm. Now the spring should come free. However, if it does not, it may be necessary to place the jack under the front crossmember and raise the car slightly higher to get it free. Since the spring didn't fall out, we're going to elevate the car slightly so the spring will fall away from the crossmember. We remember to save the rubber insulator pad sitting on top of the spring inside the crossmember, and we always use extreme caution in removing the spring. Here we have the spring and upper control arm assembly. The coil spring and upper control arm have now been removed, and we continue on to the lower control arm. To accomplish this task, we remove the nut and through bolt that connects the control arm on each side to the crossmember by gently tapping the bolt out, being careful not to strip the threads. When the bolt has been removed, the lower control arm will come out. After repeating this procedure on the opposite side, the front suspension will have been totally removed from the Pinto. Here we have the lower control arm, the attaching point for the bolt, and the upper control arm. From inside the car, we will proceed to remove the shift lever. We begin by using the appropriate screwdriver to remove the 4 screws which fasten the shift lever selector plate to the assembly or body. This plate will slide off when we remove the handle by loosening the Allen screw holding the handle to the shaft. Now, we remove the 4 bolts holding the shift lever to the floor and pull the entire unit up and out. The wire for the shift lever indicator light will still be attached and must be disconnected from the harness. This unit is now ready to be cleaned and painted for use in the assembly of our replica car. Returning to the inside of the car, we look behind the shift lever and find the emergency brake lever and housing. A screwdriver is used to pry up the housing. Then the 4 screws holding the brake lever housing to the floor of the car are removed. These screws are located to the front and rear of the emergency brake lever. If the housing is scuffed and scratched, we purchase some vinyl paint, which is available in just about any color, and spray it to coordinate with the interior of the new car. The housing is pulled up and over the emergency brake lever and set aside. Next, a socket and ratchet is used to remove the 2 bolts which attach the emergency brake lever assembly to the floor of the car. Then the emergency brake indicator light wire is disconnected. The assembly is now removed and is ready to be cleaned up and painted. The consolette, along with its mounting bracket, can also be used in the assembly of our replica car. The non-air-conditioned model is preferable. Our first step in taking out the steering column is to remove the plastic shroud covering the upper portion of the column. Next, we disconnect the electrical plugs going into the column. One plug goes to the turn signal switch, and another on top of the column leads to the ignition switch. The remaining plugs, which aren't attached to the column, are cut off. Once again, we try to leave a 12-inch lead for use during assembly. 4 bolts hold the steering column to the steering column mounting bracket. The appropriate socket extension and ratchet is used to remove the nuts holding these 4 bolts. When these bolts have been removed, the column will drop down and can easily be removed from the car. We just pull back on the column and it will slide out of the car. The ignition switch in this car is located on top of the column. The column is then stored for use in our replica car assembly. We're once again in the engine compartment where we're going to remove the brake differential valve. First, we'll remove the lines that are connected to it. The 2 lines leading from the master cylinder to the differential valve are left in place. We could remove the other lines with a wrench, but since they will be completely replaced, we'll just cut them. The differential valve is then unbolted from the fender well. The master cylinder is now disconnected from the firewall. A socket extension and ratchet is used to remove the two bolts located on each side of the master cylinder. Before we pull out the master cylinder, let's take a look at the total assembly inside the passenger compartment. This is where we find the biggest differences between the different year and model of Pintos. Here we have a brake pedal assembly from a Pinto with an automatic transmission. We have a through bolt, a bushing, and some plastic bushings on the end. It's very important that we save all of these parts. The new chassis has a number of places available to mount this bracket. This unit is from a car with a standard transmission. As we can see, it is substantially different. Here we have the master cylinder, which has been removed along with the brake pedal. We also see the brake switch for the brake lights. This has to be removed, along with the rod, by removing the clip before the master cylinder is pulled from the front of the car. We are back again inside the car, where we are going to remove the accelerator pedal, which is located just to the right of the hole in the firewall for the steering column. We simply remove the nuts securing the pedal to the firewall. Pull it off and save it for later use. Here we have the accelerator pedal assembly. We finish the work on the inside by removing the plastic crescent-shaped connectors. We leave approximately 8 inches of lead wire and cut the connectors out. Also, we want to remove the ignition switch plug. While it is possible for us to reuse the wiring under the dashboard, our feeling is that a new harness is more serviceable, with much cleaner connections than if we attempted to reuse the old wiring. We will be using old-style classic gauges, which will require extensive modifications of the original harness. We also remove the dimmer switch, located on the floor to the left of the pedals. A 10-inch lead is left when removing the part, as we will use this switch in our assembly. Using the appropriate Allen wrench, the rear view mirror is removed from the mounting tab on the windshield. We will pick up a new mounting tab at our auto supply store, rather than take the chance of breaking the glass. This is a view of the stripped Pinto. The very last item to be removed is the hood support rod. Yes, we can even make use of this item in our new replica car. Now, what do we do with our stripped Pinto? We get out the yellow pages and call a few wreckers. We're sure that we'll have no problem finding someone to pick it up. It's possible that we might even make a few dollars on the transaction. Or if we need a part later on, we should get it free. We're now finished with the disassembly of our Pinto. Now we'll take a few minutes to review the parts we've stripped from the Pinto that we'll be using in the assembly of our new chassis. We've cleaned everything up, and with a bit of elbow grease and paint, everything looks brand new. This is the radiator with a fresh coat of paint. The rack and pinion with its through bolts have been painted as well. The universal joint for the steering shaft checked out well. Everything has been painted with a rust-resistant primer. The upper and lower control arms, the spring, along with the spindle and complete brake assembly have also been inspected. The struts have been cleaned, painted, and we've checked the bushings for serviceability. We've purchased new shock absorbers from our local automotive supply store at a reasonable price. We had the car checked prior to disassembly, so we knew what was in store for us when we stripped the car for reusable parts. Here's the engine motor mount with a through bolt. Then we have the transmission. The carburetor is covered, and we had a new alternator mounted on the side, and the chain has been reattached to the engine. The adapter bracket for the motor mount that will be bolted to the chassis has been cleaned and painted. That's also true for the accelerator bracket. The transmission crossmember has been painted with a coat of rust preventative primer, and so has the accelerator pedal. We're using a rebuilt master cylinder. The brake pedal, switch, and proportioning valve are grouped together. We're not sure what we're going to do with the shift lever. Perhaps we'll have the top replated, or we'll paint it. The emergency brake handle has been wire brushed and repainted as well. The steering column has been inspected and the whole unit has been thoroughly cleaned and painted. Here we have the ignition switch, the connector for the turn signal, the lock, and the turn signal lever. We'll keep the original steering wheel for the time being. We haven't done anything with the drive shaft yet. The unit has to be shortened. At the same time, we'll paint and check it thoroughly. The wheels are still attached to the axle assembly, as well as the emergency brake cable. The bushings for the spring mounts have been inspected, and the entire unit has been thoroughly cleaned and painted. When we bolt these pieces to the new assembly, we'll basically have a brand new car. Here we have the gas tank for the assembly of the SSK replica. We can't use it for the TD replica. All the openings are sealed. Of course, the 4 original tires will be used as we build the new chassis. When we start the assembly, I think you'll be amazed at how easily these parts go together to give us a totally new running chassis for a brand new car.